Hey, what's up? We're going to go over two problems for graphing and finding reference angles. So let's go ahead and get started. So this problem is asking us to first sketch the angle that's given and then to find the reference angle. All right. So in order to graph this, what I like to do is label all of my quarters so we can find out which quadrant we land in. So this is 0 degrees where we start. Each quarter is 90 degrees more. So 0 plus 90, 90, 90 plus 90 is 180. Another quarter is 270. And if we go one more, back to the beginning, we'll have 360. So 150 degrees lies somewhere between this and this, which is the second quadrant. All right, so that's good news. So we know where it lands. And we just need to know exactly where it lands. So let's look at this. If we went 90 degrees, all right, how much more do we need to go to get to 150? So if you wrote it out in a formal equation, kind of be like this. So we've gone 90, we're figuring out what's remaining. So that would be 60 degrees. Okay, so we're going to go 60 more degrees, which is 2/3 of the way, and draw a line from the origin, creating that degree. So 150 degrees. Okay. Now, off to the second part here. It's asking us to find the reference angle. Reference angle is actually quite simple. Reference angle is the angle between that line that we created and the nearest x-axis. So there's a x-axis line here, x-axis line here. The closest one to that line, I identify as this. The closest one is here. That's the reference angle. It's not any more complicated than that. There's all these equations and stuff. I know they throw them in the book. I like this method. It seems very logical. So we just need to figure out what that theta is. So if half of the circle going from here to here is 180 degrees, okay? If we think about that, that is equal to our two parts, our 150 plus our reference angle. So we just need to figure out what that slice is. And if you did the math, you'll figure out that theta is 30 degrees. And that's the answer to this problem for the reference angle. It's as simple as that. All right, let's try this next one. So we have two things that are different. One, that this angle is in radians. So we'll talk about that. And also that there's a negative. So if you remember from the previous lesson, a radian is just a different unit, really, than a degree. They represent the same thing, like an angle. So, and negative angles are the same size of angle, but they start in the opposite direction. You go clockwise around instead of counterclockwise. So let's label the degree corners, but let's go negative, okay? So this is 0. If you went positive pi over 2, you'd be going this way a quarter. But we're going to go negative pi over 2. And we're going to end up here, okay? And if we went another quarter, another pi over 2, it'd be like 2 pi over 2 or pi. And if we add another pi over 2, this is 3/4. See? Sorry, I forgot to put negatives on these. These should be negatives. So negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. And this would be negative 2 pi if we go this way. Okay, so let's figure out which quadrant we land in. It's most easy if our quarter angles that we're using for reference are the same denominator as the angle that we're given. So this is divided by 2. So how do we make this divided by 6? We'll just multiply by 3 over 3. Okay, technically we're just multiplying by the number 1 because 3 over 3 can reduce to 1. So this is negative 3 pi over 6. You see that? And this one, if we want to have a denominator of 6, we would have to multiply by 6 over 6, which would be negative 6 pi over 6. Okay? Technically, we can change this one too, but we don't really need it. If you look at it, negative 5 pi over 6, where does it land? It's somewhere between here because it's more negative than negative 3 pi over 6, but less negative than negative 6 pi over 6. Now let's figure out how much more. So negative 5 pi over 6 and negative 3 pi over 6, how much is this more than that? So if we traveled here and we were at negative 3 pi over 6, think about how much more you would need to go to get to negative 5 pi over 6. You would have to go 2 pi over 6 more negative, because it's kind of like negative 3 pi over 6 going more negative would equal negative 5 pi over 6. So we're going this much more. Okay, then we're going to draw our line. So this is negative 5 pi over 6, like that. Okay. So we want to know the size of this line to the nearest x-axis. Okay, but it's only going to be a positive angle. It doesn't matter which direction it is in reference to this x-axis. It's always going to be positive. It's just the size of the angle. So this is our reference angle here, just like in the previous problem. Okay, we need to figure out what that is, what the size of that is. If this is negative 5 pi over 6, you see how this is pi over 6. It's another pi over 6 would get you from negative 5 pi over 6 to there. So our theta here is just pi over 6. And that's the reference angle for this problem. All right, see you guys in the next one.